Hi everybody, this is your notes video on properties of quadrilaterals. So in this video, I'm going to talk to you about 6 different types of quadrilaterals, uh, a lot of which you have already seen, like you know what these are, right? We're just going to get a little bit more specific and technical about their properties. I don't have any practice or like example problems for you in this video. This is mostly just going to go over properties. But then I have lots of examples and practice for you in the practice problems video. Okay, so let's go ahead and jump into it here. So this first type of quadrilateral is called a kite. Yes, that's actually what it's called. And it actually does look like a kite that you would fly, right? So a kite is a type of quadrilateral, which quadrilaterals are named for any shape with 4 sides where the angles add up to 360 degrees. Okay, a kite has 2 pairs of consecutive congruent sides. Okay, meaning typically that you'll have like a short pair of sides right next to each other that are congruent and a longer pair of sides right next to each other that are congruent. Okay, sides that are opposite each other, which is like if you draw an arrow or like a diagonal, like connecting 2 sides, those are not congruent. Okay, and then it has a couple other properties. Okay, one of the key ones is that the diagonals are perpendicular. So if you draw the diagonals connecting the angles that are across from each other, right, you end up with 90-degree angles here where the diagonals meet. Okay, and then you have 1 pair of angles that are congruent. Okay, so you can almost think of kites as having like a line through the middle, a line of symmetry through the middle. So you're going to have 2 angles that would fold and be right on top of each other. So in this drawing, those 2 angles are angle A and angle C that are right across from each other. Those 2 angles are congruent. Angle B and angle D, even though they're across from each other, obviously are not congruent, right? D is much smaller in this picture than angle B. Okay, right? And then another neat thing about the diagonal here is that it's a line of symmetry, like I said, like a perfect fold line, and it creates 2 congruent triangles, right? One at the top and one at the bottom, right? Or one on the left, one on the right, depending on how you look at it, okay? All right, next shape is a trapezoid, okay? You've all seen trapezoids before, and I'm sure you know, like looking at a picture, you'd be able to tell what a trapezoid was, but the actual definition is it's a quadrilateral that has exactly 1 pair of parallel sides. Those parallel sides are called bases, okay? And then the other 2 sides are called legs, very similar to, remember if when we talked about isosceles triangles, okay? One of the key properties of trapezoids is that the leg angles, okay, meaning the 2 angles that are attached to the same leg, are supplementary, okay? If you remember when we did angle relationships with parallel lines, right, we had, remember these same side interior angles right here? Okay, that those always would add up to equal 180. Okay, they were supplementary, right? So right now, essentially what we have, right, is like a simplified or condensed version of that because we have 2 parallel bases, right, cut by the transversal, which is the leg. Okay, so you have these 2 angles. So in this case, in these pictures, it's angle A and angle D, and then angle B and C are supplementary, meaning they add up to 180. Okay, now just like there's lots of different types of triangles, there's lots of different types of trapezoids. Okay, but the type that has more special properties is an isosceles trapezoid, where you have congruent legs. Okay, so the bases are not the same length, but the legs are the same length, right? They're congruent, which is what you see in this second picture right here. Okay, it's almost like if you took an isosceles triangle and chopped off the top, like chopped off its head. Okay, isosceles trapezoids have special properties, okay, which is that you have base angles that are congruent. So just like in an isosceles triangle, remember we had base angles that were congruent, Okay, same idea with an isosceles trapezoid. You have base angles that are congruent, but they work both at the top and at the bottom, right? So you have two sets of congruent angles, okay? Another property is that the diagonals are congruent, okay? And because we have these congruent angles at the top and at the bottom, the congruent base angles, then that means opposite angles, right, which are angles that are like connected by a diagonal, have to be supplementary, right? Okay. Last thing about trapezoids is they have something called a mid-segment, which is very much like a midpoint, okay? But it's just like directly in the middle of the trapezoid. Okay, what it does is it takes the legs, right, and cuts each leg in half, right? So it connects the midpoints of the legs. Okay, now that works for any trapezoid, right? It doesn't have to be an isosceles trapezoid. This works for any trapezoid. So the same way that we would calculate a midpoint by adding the endpoints. Remember, we would do like endpoint 1 plus endpoint 2, and then cut that in half, okay, if we wanted to find a midpoint. Okay, for a mid-segment, it's the exact same thing, except you're just going to add the base lengths instead of the endpoints. So like base 1 plus base 2 divided by 2. Okay, same idea. All right. Okay, so give me a second to clear my screen off, and then we're going to talk about properties of parallelograms and other shapes that fall underneath the parallelogram umbrella. All right, folks, so here we are on the second page here. We're going to talk about parallelograms as well as some other shapes that are like special types of parallelograms. Okay, so the definition of a parallelogram is it's a quadrilateral with both pairs of opposite sides that are parallel. Okay, when you're thinking about parallelograms, really what you want to think about is lots of things that are equal to each other. Okay, so meaning that the opposite sides, so sides that are across from each other, are congruent. Okay, angles that are opposite each other are congruent. Okay, diagonals, while not necessarily congruent, will bisect each other, right? Meaning that you've got two congruent parts, right? So like in this second picture right here, you can see that each of these diagonals bisects the other, right? Cuts the other in half, okay? And then the last thing you want to remember for parallelograms is that uh, the consecutive angles, right, meaning right next to each other. You heard me call them leg angles when I was talking about trapezoids. The ones that are consecutive are supplementary for the same reason that they were supplementary for the trapezoid, right? You have the two parallel lines, right, cut by a transversal, right? So we're pretending here, say this is point D, this is point A, and this is point B. Okay, again, we have these same side interior angles, right, here and here. So we would always add those, right, add those angles together, and it would have to equal 180 when we did these, the angle relationships with the parallel lines. Okay, so same idea when you're looking at a parallelogram. Okay, so the key thing to remember here is there's lots of things that are congruent, right? And most of those things are opposite each other. So opposite sides are congruent, opposite angles are congruent, and then the diagonals will bisect each other, okay? Now, what you're going to hear me talk about a lot is something called the parallelogram umbrella, okay, where parallelogram is like the overarching term. Hold on. Okay, parallelogram is like the overarching term, and then there are other things that are underneath the parallelogram. Okay, so the further down you go, the further down you go in the umbrella, the more specific or the more properties these things have to have. So the other three types of shapes underneath the parallelogram umbrella are rectangles, okay, rhombuses, and then obviously squares. Okay, squares are the most specific and have the most properties, right? Parallelograms are the least specific and have the least number of properties, right? Everything on lower levels has all of the properties of the shapes above them, right? So rectangles and rhombuses have all the properties of parallelograms plus some extra properties, okay? Squares have all the properties of everything above them in the umbrella. So all of the rectangle properties, all of the rhombus properties, and all of the parallelogram properties. Okay, so let's talk about each of those. So let's talk about the second layer here, rectangles and rhombuses, okay? So rectangles are special parallelograms, okay, that have 4 right angles, okay? So extra special parallelograms that have 4 right angles. So it has all of the properties of the parallelograms. Opposite sides are congruent. Opposite angles are congruent. Diagonals bisect each other. All of those things. But you also have extra properties. The first is that the diagonals of a rectangle are congruent. Okay? Which means like these bisected diagonals here, all of these parts are congruent. Okay? Then the last thing, obviously, is that all angles in a rectangle are congruent, right? They're all 90 degrees, okay? All right, so those are your 2 extra properties, right? You have 2 extra properties for rectangles, okay? For rhombuses, right? A rhombus is a special parallelogram that has 4 congruent sides, okay? And it has 3 extra properties, right? So obviously this is my first extra property that you have 4 congruent sides, okay? Another extra property is that the diagonals are perpendicular. So they intersect, right? The diagonals intersect and form right angles, okay? Obviously the diagonals are not congruent like the rectangle, right? Usually you'll have a longer diagonal and a shorter diagonal, okay? But they are perpendicular, so it forms 90-degree angles here where the diagonals meet, okay? And then in a rhombus, the diagonals bisect the angles, okay? So all 4 of these vertex angles, right, A, B, C, and D in this picture are all bisected by the diagonals or cut in half, which means the 2 parts of each angle, right, when the diagonals are drawn, are congruent, okay? Right? So those are your extra properties. So I have 1, 2, 3. So I've got my 3 extra properties. Okay, and again, this also has all the parallelogram properties. So diagonals bisect each other, opposite sides are congruent and parallel, opposite angles are congruent, etc. Okay, then the very last type of quadrilateral is a square, right? Which combines all the properties of the parallelogram. So opposite parallel sides, opposite angles, opposite congruent angles, diagonals bisect each other, okay, with the extra rectangle properties, meaning you have all angles that are congruent and all diagonals that are congruent, plus the extra rhombus properties. So the perpendicular diagonals, right? So the extra rhombus properties are the perpendicular diagonals and the 4 congruent sides, and then you have the bisected angles, okay? And then the extra rectangle properties are the congruent diagonals and the 4 right angles, okay? So in the umbrella, All right, if we kind of go back up to our umbrella, the square has all of the extra properties of the rectangle and the rhombus, plus the properties of the parallelogram. Okay, so that is essentially it for this video. Okay, in the next video, I'm going to show you how to take all of these ideas and properties and use them to write equations. Okay, and it's going to be very similar to what we've done with a lot of other things, right? Whenever you have congruent things in geometry, we set them equal to each other. Whenever you have supplementary things, then that means they add up to 180. Okay. Whenever you have a midpoint, right, you have the two parts that are equal, right, or a bisector. Whenever things are perpendicular, then that means you have a 90-degree angle right there. Okay. So lots of things that you've seen before. We're just going to kind of put them in a new context here with these quadrilaterals. All right, you guys. So I will see you in the next video for some practice problems. Bye, everybody.